Okay, in this section, we are going to explore the shape on cylinder. So there are cylinder is a very common shape that you'll see around in your real life. If you look around like your canned food or your sometimes like stationery holder, it can be in the shape of a cylinder. Okay, so there are two kinds of cylinder. It can be a closed cylinder or it can be an open cylinder. So a closed cylinder will have the top covered and the bottom covered. So that is called a closed cylinder, or sometimes we'll call it like a solid cylinder. Okay, so in this case, right, the volume of a cylinder, if you take a look here, is pi r squared times height. So where is the component here? So the radius will be the radius of the circle, and the height will be the height of the cylinder. So I would like you to visualize this part as pi r squared times height. So actually pi r squared is like a circle. So I want you to imagine the volume as in like how many circles are you stacking up? So how much circle you are stacking up? So this is like the height that you stack up the circle. So for cylinder, you can imagine, okay, so it's like you draw out a circle, then you try to stack up. So the taller you stack up, the more volume it will have. So you can imagine a cylinder as a stack of circles. So that's why it's pi r squared times height. Okay, for the surface area, there are two components. So let me explain the two components first. So there will be a curved surface area. So this part is the curved surface area. So it is the one that is at the side. Okay, my cup is not exactly cylinder, but it's the part that's on the side. Okay, so this is the curved surface area. So this part is the curved surface area. Okay, and then here, there are 2 pi r squared. Okay, so where does it come from? It comes from the top circle. So this one can be the top circle, and then this one can be the bottom circle. So you visualize the surface area piece by piece. So there's this curvy side, there's a bottom, there's a top. That's what make up the total surface area for a closed cylinder. So right now, if you understood what is a closed cylinder, then we explore the idea of open cylinder. So open cylinder means it's open at the top. So this part here is open. So when will you see this, right? It's like your pencil holder, okay, your cup holder. Okay, so you will get, so it's something like this one. Okay, so this one is circular base. So if I open it up, then that will be an open cylinder. Okay. So does it make a difference to the volume? The volume is still a stack up of circle. It is still a stack of circle. So it doesn't make a difference. But the surface area, it does make a difference. Because right now, if you explore the surface area, you realize that you only got the base and you got the side. So the surface area is only pi r squared plus the curvy part. So you got to make some sense out of the surface area. So it's a very common sense. There's only a base and there's curved part. So for a closed cylinder, right, there's a top and there's a bottom and there's a curved part. It doesn't change your volume. Okay, so you have to think in a composite figure. So, for example, in Sec 2, you will encounter this shape, okay, a cylinder with a cone. So certain part will be covered up in a composite figure. So you got to like use a bit of common sense. Don't apply formula blindly. Okay. So with this one, with this introduction, right? Okay, I will show you the example on example 7. So now I want the cylinder. So for part A, it's quite easy. So for part A, right, this is the radius, and then this is the height of the cylinder. So if I would like the volume of the cylinder, so if you're not very used to it, right, you can just write the formula down first. So it will be pi r squared times height. So again, my habit, my habit is I will just press it in terms of pi before I punch the pi. So pi can be 3.142, can be calculated pi, unless otherwise stated. So my habit is I will use a calculator pi. So when I use the calculator pi, if you look at my answer look very, very different from if I round off to 3SF. So before I round off to 3SF and after I round off to 3SF, it looks a bit different. So some students, right, they may think that their answer is wrong, but it's actually correct. So the answer will always be 3SF. Okay, so then we explore the surface area, total surface area. So for the total surface area, we got the top and bottom, which contribute the 2 pi r squared. And we got the curved surface area. So plug everything in. So if you look right, I always do it in terms of pi first. The way you do it also matter. Some people do it in a very messy way, in a not organized way. You cannot even check for your own careless mistake. So I will always leave my answer in terms of pi before I punch out my pi. And do take note, sometimes during exam, they will tell you, leave your answers in terms of pi. So some of you will be, what do they mean by leave it in terms of pi? If they wanted you to leave it in terms of pi, this is the answer. So this is the answer if they would have wanted you to leave it in terms of pi. So I'll leave it in terms of pi with the units. So if they didn't want to leave it in terms of pi, I will punch out with the pi. And then this one, if I round off to 3SF, that will be the total surface area. So before rounding on and off and after rounding off, it looks a bit different. Okay, but that is the 3SF answer. Okay, so that's how I make use of the formula to find the volume and surface area. So I'm going to erase this part. I'm going to explore the question in part B. Question in part B is working backwards. Okay, so I'm going to erase off this. Make sure you already copied down. So for part B is another cylinder. So it's a different dimension. So if it's not drawn for you, you can help yourself by drawing it out. So the diameter is 0.4 meter. So which means, right, this part is 0.4. And I do not know the height, but I do know the volume. So in a way, it's a working backwards to find the height. Okay, so I'm going to set up the formula first. So I'm going to get my radius. I'm going to set up my volume of cylinder. So volume of cylinder pi r squared times h. It's very much the same way like I teach you in area and perimeter. If you need to find algebra, right, you do the formula first, and then you set it up like an equation. So this is my volume. So 0.04 pi h is going to be 0.9 meter cube. So from here, your job is to find h. You divide both sides by 0.04 pi. Punch carefully. It is a bit like volume divided by base area. So this base area is pi r squared. So it's the same idea as volume divided by base area. So this is like the volume. This is like the base area. The base area is the pi r squared. So we got this part here. So I'm going to divide by the base area. Okay, I'll punch out my pi, calculate the pi. Okay, so I will get 7.16197 meter. So again, round off to 3 SF. So it's like working backwards. So of course, they can also ask you to work backwards to find the radius if they have given you the height. Okay, so that is the one. You must be able to do forward and backward. Calculate volume and surface area. And or if you are given volume and surface area, you can calculate backwards for any missing radius or height. Okay, so the next question is a bit like a hollow cylinder. So it's hollow, that's why there is an internal diameter and then there's an external diameter. And the volume that you actually use to make the pipe is here. So this part is the volume. So there's a circular ring, and then you use the material. So there are certain thickness to make the pipe. So your job is to calculate the material to make it into a pipe. And your job is to leave your answers in terms of pipe. So how are you supposed to visualize this? You're supposed to visualize it as a big cylinder, something like from a big cylinder. You're going to drill and you dig out another smaller cylinder. So the materials that is supposed to make this pipe is something like a big cylinder, and from the big cylinder, you dig out a small cylinder. So that's why there's an internal diameter and there's an external diameter. So the external one is the one that is the bigger part. So the external diameter is the one that is responsible for the big cylinder. Okay, so I'm going to calculate the big cylinder first. So be step by step, label, and make sure you're very comfortable with what you're doing. So step by step, not to get confused. So the radius will be the diameter divided by 2. So from here, I can find the volume of the big cylinder. So that is pi r squared times height. Okay, this one, they wanted me to leave it in terms of height. So don't press the pi. So it will be 259.2 pi centimeter cube. Then after that, I'm supposed to find the small cylinder. The small cylinder is the one that is inside. So you're going to dig up that cylinder. So the cylinder, the small cylinder. The small cylinder is the one inside, so you should take the internal diameter divided by 2. So in such a case, the volume of small cylinder pi r squared times height. So from here, I can find the volume of the material. So how much material used? So material is the volume, okay, that we're talking about. So in this case, right, it should be the big cylinder minus the small cylinder. So leave your answer in terms of pi. You realize I didn't punch the pi out. Okay, so this is the idea of like a big cylinder and a small cylinder, and a sample where they ask you to leave your answer in terms of pi. So do take note when you're doing this section, you got to remember whether and read carefully whether is it an open cylinder or a closed cylinder. Okay, so that's the part on cylinder.